Welcome to Remathable. Today we're going to touch upon trigonometry. Whether you're starting out or you need a refresher, you're in the right place. In this video, we're going to break down what trigonometry is all about. Okay, so first we're going to discuss right angle triangles. Right angle triangles. We're going to learn how we can apply Pythagoras Theorem and trig ratios. This is in case you're dealing with right angle triangles. And then we are going to explore the sine and cosine rule, which is basically for non-right angled triangles. We're going to discuss when and how to apply sine rule and cosine rule. We're also going to learn how to calculate the area of a triangle when the height and the respective base is not given. Area of triangle. So basically it would be a non-right angle triangle, okay? And then finally, we are going to wrap up by looking at some supplementary identities. So this is how the video is basically going to be organized. It's a very rough outline of what is going to follow. This video focuses especially on core trigonometric concepts. Topics like angle of elevation and depression and bearings will be covered in the next video. If this sounds like something you've been looking for, give the video a quick like and subscribe so you're always up to speed with the new lessons. Now let's jump in. I hope all of us are aware of the three types of triangles that exist. Okay, so we have an equilateral triangle, all three sides are equal and all angles therefore are equal to, okay. Then we have an isosceles triangle. Okay, so an isosceles triangle has two equal sides and therefore two equal angles, okay? And the third type is a scalene triangle with no equal side or equal angle. All sides and angles are different. For isosceles, we have two equal sides or angles. All three sides angles are equal. Okay, now we have a fourth kind of triangle, a right angle triangle that we're going to discuss in detail. Okay. So a right angle triangle is one which has a 90-degree angle. Okay, see. Okay, so this is a 90-degree angle. You should also be able to label the sides of a right angle triangle. So the side which is opposite the right angle triangle. Okay, so this is the right angle triangle, the right angle, and the side which is opposite to the right angle is basically this one. So this side will be known as the hypotenuse. Okay, and the other two sides are known as the legs of the right angle triangle. When we're going to discuss the trig ratios, I'm going to get into more detail, but for now we're just going to label it as A and B. Okay, and the hypotenuse as H. Okay, so here you should know that the length opposite to the right angle is the longest side of the right angle triangle and is known as the hypotenuse. Now, when we have right angle triangles, we can apply Pythagoras theorem, or we can apply trig ratios, trigonometric ratios. Okay. Pythagoras theorem is used to calculate a missing length, of the right angle triangle. Okay. And trigonometric ratios can be used to calculate the length or an angle. Okay. Now, what is the Pythagoras theorem? The Pythagoras theorem basically states that h square is equals to a square plus b square. Okay, so h square, the square of the longest side, hypotenuse, is equal to the square of the legs of the right angle triangle. Okay, so first we are going to focus on Pythagoras and later we're going to get into trig ratios. Okay, so for example, okay, so this is 3 centimeters, this is 4 centimeters, and this is x. Okay, and you're required to find the value of x. What are we going to do? It is a triangle, so the first thing we need to see is whether it is a right angle triangle or a non-right angle triangle. This is a right angle triangle, so we can apply Pythagoras, plus only the lengths are involved, right? So Pythagoras theorem can be applied safely. So the next thing that we need to figure out is the hypotenuse, the longest side of the right angle triangle. So this is the right angle. The length opposite to it is this x. So x is going to be the hypotenuse. So x square is going to be equal to 3 square plus 4 square. So x square is equals to 9 plus 16. X square is equals to 25. To get rid of the square, we're going to take it to the other side and it's going to become under root 25. And we always add a positive negative sign outside the square root. However, because we're discussing the length here, x is the length, it cannot be negative, right? So we're going to ignore the negative value of x and we're going to choose x is equals to 5 centimeters. Okay, let's do another quick example. Okay, so this is 5, this is 13, and this is y. Again, the first thing to see or notice is whether the triangle is a right angle triangle or not. It is a right angle triangle plus only lengths are involved, so we can safely apply Pythagoras theorem. But before doing that, we need to see which is the longest side or the hypotenuse. So 13 is the longest side of this right angle triangle. So if we apply Pythagoras, it's going to be 13 square is equals to 5 square plus y square. We're going to take this 5 to the other side. So it becomes 13 square minus 5 square is equals to y square, which is exactly the same thing as y square is equals to 13 square minus 5 square. Okay, so this becomes y square is equals to 169 minus 25. Y square is equals to 144. Y is equals to under root 144, which is equal to 12. So y is 12 centimeters. Okay. This is not at all a complicated topic. Okay, let's do another one where they can try and confuse you by using surds. Okay, so the first thing to notice, is it a right angle triangle? Yes. Then we need to figure out which side is the hypotenuse. So under root 10. Okay, so what are we going to do? We're going to apply Pythagoras. You're not going to get confused. You're just going to apply what you've learned. So hypotenuse is under root 10 square should be equal to 1 square plus x square. Okay, so we all know that the square root and square will get cancelled out. So what do we have? We have 10 is equals to 1 plus x square. 10 minus 1 is equals to x square, which is the same thing as x square is equals to 10 minus 1, which is 9. So x is going to be under root 9. X is equals to 3 centimeters. Okay, I hope you have no issues in applying Pythagoras theorem, but you need to be very careful. You can only apply it to right angle triangles. Okay, let's do another quick example. Very quick example. So we have two unknown sides, and one side only the hypotenuse is given. Okay, so the length opposite to the right angle is going to be the hypotenuse. So 10 square is going to be equal to x square plus x square. As long as we have one unknown in the equation, we can find the value of that unknown. Okay, so this is going to be 2x square is going to be equal to 100. X square is equals to 100 divided by 2. X square is equals to 50. X is under root 50. Okay, they can also test you in a word problem, such as the one that we're going to discuss. So a 4-meter ladder rests against a vertical wall with its foot 2 meters from the wall. How far up the wall does the ladder reach? Okay. A 4-meter ladder rests against a vertical wall with its foot 2 meters from the wall. How far does the ladder reach? Okay, so the first thing I would suggest is to quickly draw a sketch of whatever is stated in the question. Okay, so a vertical wall, let's draw the vertical wall first. A 4-meter ladder. Okay, so the ladder is, so a ladder stands against the wall like this, right? This is how a ladder is. But for simplicity, we're going to just assume that this line is the ladder. Okay, so it is a 4-meter ladder with its foot 2 meters from the wall. So this is the wall and this is the foot of the ladder. So this is 2 meters apart. Okay, so 2 meters. Vertical wall means that it makes a 90-degree angle with the ground or the floor. Okay, how far up the wall does the ladder reach? So what are we required to find? We're required to find this height. Okay, so this is going to be x. With the sketch drawn and understood, I think there's no problem in finding the value of x. You just have to apply Pythagoras, angle opposite to the length opposite to the right angle. Okay, so this is good, which is 4 meters. So 4 square is equals to 2 square plus x square. X square is equals to 4 square minus 2 square. X square is equals to 16 minus 4. X square is equals to 12. X is equals to under root 12, which turns out to be 3.46 meters. Okay, so I think Pythagoras won't be tested in a very technical way. It is a pretty simple and straightforward concept, and hopefully you've understood it well. Okay, now let's move on to our second part, which is what? The trigonometric ratios. Okay, again, be careful, they can only be applied to right angle triangles. But before we discuss trigonometric ratios, I want you to learn how to label the sides of a trigonometric, the sides of a right angle triangle. Okay? Okay. Okay, so we are clear about the hypotenuse. The length opposite the right angle is the hypotenuse, right? So we're going to label this as H. Now, what about the other two sides? The side opposite to the given angle. Okay, so theta is just any angle, an unknown angle, or they might have given us the value of theta. So the side opposite the given angle is known as the perpendicular or the opposite. Okay, this is the perpendicular. And then the third side, which is left, will be the base or adjacent. Okay, so you need to understand and you need to label the sides of your triangle before you apply any trigonometric ratio. Okay, so the side opposite the right angle is the hypotenuse, it is the H. The side opposite the given angle is perpendicular or opposite, and the third one is going to be the base or adjacent. Okay, now what is sine? Sine of theta is b over h. Cos of theta is b over h. Tan theta is b over b. Okay, so sine theta is perpendicular over hypotenuse. So perpendicular over hypotenuse. Cos theta is base over hypotenuse. Tan theta is perpendicular over base. Okay, don't worry if you don't understand it. I'm sure it will become more clear as after we've discussed a couple of examples, but you need to memorize these. Okay, So there are a lot of ways that students utilize in order to memorize these three trig ratios. But my suggestion to you would be that just memorize. They're very easy to memorize. Just memorize them directly. So some of the students in my class, they like to keep the all the ratios in mind by using this technique where they say that some people have curly brown hair through proper brushing. Okay, so you can use that, or you can just simply memorize. So sine theta is P over H, cos theta is B over H. Okay, so P over H is sine theta, B over H is cos theta, and if you just remove the H's, so you'll be left with P over B. So that is tan theta. Okay, so sine theta is P over H, cos theta is B over H, and tan theta is P over B. Okay, now let's tackle a couple of questions so that your confusions regarding these trigonometric ratios are clarified. Okay, does not look like a right angle triangle. Okay, so let's say that this is the information that is given to us. Okay, so now we cannot apply Pythagoras to find xy because the third side is not given to us. But we have an additional piece of information, which is this angle. So let's begin by labeling the sides of our triangle. Okay, so the length opposite to the right angle is the hypotenuse. So this is going to be h. The side opposite to the given angle is p. So x is going to be p, and the third side automatically becomes b. Okay, now we need to find x. X is the perpendicular, and what is given to us? Base is given, right? We need to find P, and B is given. So which ratio connects P and B? Tan theta, right? So tan theta is equals to P over B. Let's plug in values. The value of theta is 30. So tan of 30 degrees is going to be P, which is X, and B, which is 8. Okay, so we're going to take 8 to the other side and we're going to multiply it with, so X is going to be 8 tan of 30 degrees. Okay. Okay, so your calculator may work slightly differently to different calculators. So I'm not going to be specific about which calculator you're going to use, but please make sure that you're familiar with your own calculator and how the trigonometric functions on your calculator work. Okay, all you have to do is that you simply have to insert this entire thing into your calculator. Make sure that the mode of your calculator is set to degrees and not radians. Okay, and just plug this into your calculator and you should get x is equals to 4.62 centimeters. So you can round off your final answer to 3 significant figures. But again, I cannot stress enough that please do not round your workings. So while you're working, you're not allowed to round off anything. Okay? You can only round off your final answer to 3 significant figures. And in case of angles, you can round them off to 1 decimal place. Okay, let's do another example. But before doing that, let's just copy this. Okay. Okay, let's do another example. Okay, so this is 25. This is x, this is 15. Okay. Okay, first step to check whether it's a right angle triangle or not. It is indeed a right angle triangle, so we can safely apply either Pythagoras or trig ratios. Now, since an angle is involved and we do not have the third side, we have an unknown side, 15, and we do not know what this side is, so we cannot apply a Pythagoras. So we're going to have a look at trigonometric ratios, but before doing that, we need to label the sides. Okay, so the side opposite to the right angle is always the hypotenuse. So we're going to label it as H. The side opposite the angle is B. So this is going to be P. And the third side automatically becomes the base. Okay, so now we need to find P and we're given H. So which ratio connects P and H? Sine theta. Okay, so sine theta is equals to P over H. Let's plug in values. The value of the angle is 25. Perpendicular is x. H is 15. So x becomes 15 into sine 25. Please and insert this into your calculator and you should get x is equals to 6.34 centimeters. Okay. Okay, let's do one more example. First thing, is it a right angle triangle? Yes, it is. Then let's just label the sides. So the side opposite the right angle is going to be the hypotenuse. The side opposite this angle is going to be perpendicular. And the third side becomes the base. Now we need to find the hypotenuse and we're given the base. So which trigonometric ratio connects B and H? It's cos theta, right? So cos theta is equals to B over H. The angle is 75 degrees, base is 8, H is Y. Okay, so we're going to take Y to the other side and we can bring this cos 75 to the denominator here. Okay, so Y is equals to 8 over cos of 75 degrees and you should get Y is equals to 30.9 centimeters. Okay, now this is the case where the angle is given to us. They can also ask you to find the angle, and that is where we're going to use our inverse trigonometric ratios, which are written as sine inverse, cos inverse, tan inverse. Okay, so you're not going to read this as sine raised to the power -1. That is incorrect. This is sine inverse, cos inverse, and tan inverse. These are the inverse trigonometric ratios. Okay, and they're used to find angles. Okay, so let's do an example. 5, 10, and you need to find theta. Okay, so the question asks you to find the value of the angle theta. Okay, so first thing, it is a right angle triangle. Next thing, we're going to label the sides. So the side opposite to the right angle is going to be the hypotenuse. The side opposite to the angle is the perpendicular, and the third side becomes the base. Okay, now what is given to us? We are given the perpendicular and the base, and we need to find the angle. So perpendicular and base are connected through tan, right? So tan theta is equals to P over B. Let's plug in the values. Tan theta will remain as theta. P is 10, B is 5. So tan theta is equal to 2. Now to find an angle when we know the value of its tangent, So we know tan theta is 2. What are we going to do? We're going to use the inverse tangent button on the calculator. Okay? On many calculators, you will see the button tan with tan inverse above it. And to activate the inverse tangent function, tan inverse, you need to press the shift button or to press the shift button and then press the tan button, and it would give you tan inverse. Okay, so please use your calculators and see how they work before the exam. Okay, make sure that you're comfortable with your calculators. So what are we going to do? We need to find the value of theta, and we're going to take tan to the other side by taking the inverse of tangent. Okay, so theta is going to be tan inverse of 2. Okay, and this is a function on the calculator. Usually it is on the tan button. Okay, it is above the tan button. So you're going to press tan inverse on your calculator, and then you're going to enter 2 and the value, and you will find the value of theta, which is in this case 63.4349, and you can round off angles to one decimal place. Okay, I hope you're not confused. Let's do another example. This is a past paper question. Okay, so this is a right angle triangle. PQR, angle is 18. This is 4.5. Okay. Okay. So let's first, it is a right angle triangle. The first thing that we need to notice or check, and then we need to label the sides. So the length opposite to the right angle is hypotenuse, the length opposite to the angle is perpendicular, and the third one becomes the base. Okay, so we're given the hypotenuse and we're given the angle. What are we required to find? Oh, okay, so the question says that find PQ. Okay, PQ is the base. So we have the hypotenuse, we need to find the base, and we are given the angle. So H and B are connected through cos. So cos theta is going to be B over H. Cos theta, let's plug in the values. The value of theta is 18. Base is unknown. H is the hypotenuse, which is 4.5. We're going to take 4.5 to the other side. So base is equals to 4.5 into cos of 18 degrees. Okay. And base, if you use your calculators to find the value of this expression, you will get 4.279. Okay. So basically PQ is equals to 4.28 centimeters if you want to round it off to 3 significant figures. Okay, let's do another example. So this is A, B, and C. This is theta. This is 6, and this is 10.2. And they're asking you to find angle ABC. Okay, so the hat notation has been discontinued. So initially, you might find some questions in the past paper, they've written angle like this. So angle ABC is exactly the same as writing angle ABC. Okay, so this is the hat notation, and this has been discontinued now. Okay, so ABC. So this is the angle that they're talking about, right? So we need to find theta. Let's first see what we're given. Okay, so this is a right angle triangle. Let's label the sides. The length opposite to the right angle is the hypotenuse. The length opposite to the angle is perpendicular, and the third one becomes the base. So we're given the perpendicular, we're given the hypotenuse, and we need to find the angle. So perpendicular and hypotenuse, they are connected through sine theta. Okay, so let's work. Sine of theta is equals to P over H. Let's plug in values. Theta is theta. Perpendicular is 6. Hypotenuse is 10.2. Okay. And then to find the value of the angle, we're going to segregate it from the sine. How? By taking it to the other side and taking the inverse of sine. So theta is equals to sine inverse of 6 divided by 10.2, whatever the answer is for this. And then you should get theta is equals to 36.0318. You can round it off to 36.0 degrees. Okay. We can also do another past paper question. Okay, so let's label the triangle A, B, C, D. This is the right angle triangle. This is 10.2. BD is 14.3, and the question asks you to find AD. Okay, AD. Okay, first thing, is it a right angle triangle? Yes. So we can apply Pythagoras and trig ratios. So let's see. We have 14.3. Okay, there's another piece of information given. This is AC is 6 centimeters. Okay. So let's first focus on the triangle ABC. It is a right angle triangle. AC is 6, AB is 10.2, so we can apply Pythagoras. Okay, so let's draw this triangle separately outside so you have no confusions. This is A, B, and C. AC is 6, AB is 10.2, and we need to find BC first. Okay? Why do we need to find BC? Because we need to find AD, right? And the only way to find AD is to utilize the triangle BCD. BCD is a right angle triangle, right? And we know what BD is, and we need to find AD. We know what AC is. So if we find BC, then if we just look at triangle BDC, this BDC, and we have 14.3 and we have BC, we will be able to find DC. Okay? Okay, so let's label the sides. This is the hypotenuse, and for Pythagoras, you just need to know which is the longest side. Okay, so 8 square is equals to A square plus B square. H is 10.2 square. A square plus 6 square. So A square is going to be 10.2 square minus 6 square. What is the value? Let me find. Okay, so 10.2 square minus 6 square is 60. A square is 68.04. A is going to be under root of 68.04. So it is 8.24863, can round it off to 8.25 centimeters. Okay, but since this is not what you're required to find, we've calculated the value of BC, and you need to utilize this length in your workings later, so you're going to use this value and not the rounded off value. Okay, had this been your final answer, you could have just rounded it off to 3 significant figures and you could have just left it right there. However, because we're going to utilize the value of BC later, we are now going to round off the value. Okay, so now what do we have? We have BC, we have BD. Let's draw the triangle BDC separately. So this is 8.248. This is 14.3. Let's find DC. DC is X. Okay. So DC is going to be, this is a right angle triangle. Let's label the sides. Hypotenuse, and this is A and B. So 14.3 square is x square plus 8.248 square. So I would suggest that since you're going to have this value on your calculators already, you can just enter this on your calculator. So 14.3 square minus, okay, so 14.3 square minus brackets answer square. So this is going to give you the most accurate answer. Okay. So x square is equals to 14.3 square minus 8.248 square. And then to remove this square, you're going to take the under root of the answer of this, right? So that should give you the value of, let's calculate it very quickly. Okay, so square minus 4. So this gives you 136.45. Square root of 136.45 is x is equals to 11.6811. Now the question asks us to find the value of AD, and we have calculated the value of DC, right? Since this is 6, so we have DC. Okay, so we have the value of DC. DC is 11.681, and we know that AC is 6 centimeters, and we need to find the value of DA. So what are we going to do? We're going to subtract 6 from 11.68, which gives us 5.6811817. So what is the value of AD? It is 5.68 centimeters.